Okay, so in section 5.3, we're still dealing with the normal distribution and all its properties, but we're going to kind of work backwards now. So if you notice the way this first question is framed here, use the standard normal table. We're going to use the calculator. We won't use the standard normal table, the calculator. We have it. If you paid for it, you might as well use it. To find an area that corresponds to 0.882, right? So this is an area to cumulative area. So when we talk about a cumulative area in the normal curve, it means area to the left, right? Because we always read anything left to right. So if it's a cumulative area, the total area under the normal curve, remember, is 1. So the cumulative area, if I get to here, maybe is like 30%. And when I get here, it's 50%. And then 80%, right? And so on. So cumulative is always area to the left, right? So they're telling me, look, the z-score is 0.882. So I know the z-score lives right here. What we want to, I'm sorry, they're telling me the area is 0.882. So I know the area to the left of the z-score is 0.882, but I don't know what the z-score is. So I'm trying to figure out what z-score would live here that has an area to the left of it of 0.882. It's a reverse engineering of the problems we've been doing, right? We've been having z-scores and finding the area under the curve. Now we have the area and we want the z-score. So if you go to the same place we've been going to, second bars, you're going to see right away you have your normal CDF, and right after that is inverse norm. Okay? So inverse norm asks you basically, what is the area to the left that we're dealing with or looking at? And they give that to us. It's 0.882. Okay, so I'm going to put in 0.882. By the way, you're not always going to get area to the left. We'll cross that bridge when we get to it. And you know we're probably eventually going to add some problems where the mean and standard deviation aren't 0 and 1. But my area to the left is 0.882. Sometimes I have area to the right, but I'm always going to have to put in an area to the left here. So for example, if I wanted to know what's the z-score for the top 10%, well, that would be inverse norm of 0.9. I still always need the area to the left. Okay, so press enter. And then what it kicks back to us now is not a probability anymore, it's a z-score. So to 2 decimal places, this would be 1.19. I'm not sure how many decimal places they want here. 3. So we'll stay with the 1.185. Okay, we're good there. All right, let me jump to number 5. So this frames it a little bit differently. You're going to see a z-score that corresponds to, you have P33 here. So P stands for percentile, and then the 33 is the percentile. So whatever that number is, if that number were 3, that would mean we'd want the 3rd percentile, right? And remember, percentile means, this was on our first test, the proportion of observations below a particular number. So whatever our percentile is, the 33rd percentile will be, so this is the 50th percentile, right in the middle. 33rd percentile is going to be somewhere around here because the area to the left is 33%. So it's the same command again, it's inverse norm, except this time my area to the left is 0.33 for 33%. We can just delete that one. Okay, and then I still need my mean and standard deviation, or 0 and 1 respectively. So negative 0.44 basically. And now we're at 2 decimal places. Okay. Let's have a look at 6. P82, so that's the 82nd percentile. So pretty easy. Second enter on that. This time it's going to be 82, I believe, right? So we just arrow back. .92. 2 decimal places. Okay. Let's take a look at 8. That might be a little bit different view for us. Okay, so now we want to do the same thing, except now we have a graphical representation of it, which I think makes it even easier. But I'm trying to find the z-score that lives here so that the area to the left is 0.2296. So again, as long as we keep dealing with z-scores, the mean and standard deviation stay to be 0 and 1. So this time we have 0.2296, comma, 0, comma 1. Okay, so negative 0.74. Check that out. Very good. Okay. So let me jump to number 10, see if that looks a little bit different. Okay, so now I don't have any graphical picture, but find the z-score that has 12.3% of the distribution to its left. So this is the same thing we're doing, except we just have to change 12.3% to a decimal. So 12.3% is 0.123. 1, 2, 3, and we'll delete that. So negative 1.16. Okay, so that was number 10. Let me take a peek at number 12 in case that one looks a little different. Try to get multiple different looks to this. Okay, so here we have 92nd percentile, 63rd percentile, first quartile. So area to the left for 92nd percentile is 0.92. Area to the left for 63rd percentile is 0.63. And the first quartile, the area to the left of that would be 0.25. Okay, and still, now what we have to be aware of here is that our mean and standard deviation have now changed. They're 5.7 and 2.5 respectively, so this is going to be a little bit different. So I still want inverse norm again. So the first one was 92nd percentile. So we start with 0.92, comma, and then I need to double back on my mean and standard deviation. 5.7, 2.5. 5.7, 2.5. Okay, so I get 9.21. Check that. Good. 63rd percentile. So easiest way to get that is just second enter again. Just change the 0.92 to a 63. Boom, boom. 0.653. Uh-oh. Oh, 2 decimal places, so double check there. Oh, 6.53. Getting a little bleary-eyed here. Okay, and then finally the 25th percentile. Same thing, we'll second enter again. Just change that 0.63 to a 0.25. .01. So let's jump to number 16. That's going to look a little bit different, I think. We have more context to the rest of these. Okay. So what is the maximum score that can be in the bottom 10%? So bottom 10% that's area to the left, okay? And we need to find our mean and standard deviation over here. They're 3.4 and 0.87 respectively. So the first one, pretty easy. Second one's going to require a couple of steps for us. But bottom 10% is the 10th percentile. So I can just change that 0.25 to 0.1. Then I need a comma, and then I need to double check that mean and standard deviation. 3.4, 0.87. 3.4, comma, 0.87, and we can delete the rest of this. So 2.29. Okay, I already filled this one in. So rather than resetting this, so yeah, 2.29, you can see that. I'm going to show you how I get the other two. So the next question says the middle 80%. So think about what middle 80% would mean here for us, right? Middle 80% means that from here to here is 80%. So the area I'm shading in is 80%. If that were to happen, if I shaded in 80% in the middle, there'd be 10% in this tail and 10% in this tail. So to find those two numbers, I need to inverse norm 10%. And then over here to get this one, I'd inverse norm 90% because it's 80 plus this 10, top 10%, right? So that leaves me with 80% in the middle. Well, I already did the bottom 10%. That's 2.29. So to find that top cutoff, we have to change that 0.1 to a 0.9 because it's 80% plus the one tail that has 10% in it. That'll be a total of 90%. Okay. Go enter, and I see that it's 4.51. And that's how I got that number. So the middle 80% is 2.29 to 4.51. Okay. And let's have a look at number 17. Let's see what 19 looks like. Okay, yeah, so 19 is a little bit different. It's not going to be entirely calculator driven. This one might be tough for me to do a video of, but I'll go ahead and explain the algebra to you and see if you can arrive at it. But what I'm looking for here is the mean. They're saying, what should the mean be? We know the standard deviation is 0.09. So what we would make use of here is our z-scores. So the z-score is, remember, the standard normal score is the raw score minus the mean divided by standard deviation. Okay, so we can find what that z-score is going to be so that the cup overflows 10% of the time, right? So the z-score is going to be, we're going to inverse norm 0.9, right? I only want to go over this mean far enough so that it overflows 10% of the time. So I'm going to inverse norm 0.9. I'm going to get the standard normal score for this. Okay. So a z-score of 1.28 is going to be in that top 10%. All right, a z-score of 1.28. So we want this z-score of 1.28. So that's the best I can do with my equation for this draw tool that I have here. But 1.28 is going to be the z-score so that if the cup is 16 ounces, right, then that raw score is 16. If we go over 16, we're going to overflow it, right? So if our score gets to 16, we want that to be the top 10% cutoff. So we're trying to figure out what should this mean be so that that's going to happen. And then our standard deviation is 0.09. So it's just an algebra equation. You're going to multiply 1.28 by 0.09, subtract 16. You'll get a negative number, but you're just going to change that to positive because x also has a negative number in front of it. So that's where I get the 15.88 ounces. If you solve that equation that I just had on the previous page, you'll get 15.88 ounces. Let me take a look at 17. All right, so yeah, 17 will be a good one to wrap up with here. I think it'll give us a good example. What's the minimum red blood cell count that can be in the top 23%? Okay, so to get to the top 23%, remember the calculator always deals in the economy of area to the left. So to find that top 23% cutoff, I have to do 1 minus 0.23. So that would be 0.77. And now I just need to double back and see what my mean and standard deviation are. The mean is 5.5 and the standard deviation is 0.4. Let's see what we get. 5.7 795. That's going to round to 5.8. See what we're supposed to round to here. So yeah, to 2 decimal places, though I think that's still 5.8. Yep. Okay. And then bottom 13%, you're just going to inverse norm 0.13. That one should be pretty easy for you, right? We would just change this. We didn't have to subtract from 1. It's the bottom, right? Top 23%, you always need area to the left, right? Now it's bottom 13%. Okay. So like top 23%, I realize is up here, but this calculator always needs an area to the left. So if there's 23% up here, there's 77% to the left. So this is going to be 13 this time because we went bottom 13%. 5.05. Okay, so I hope that that's helpful in getting you through the this particular section, 5.5 or 5.3 rather, yeah, good luck with the problems there.